This lesson is 8.5, Day 2, Tangent Ratios. Warm up. Using your calculator, find all the tangent ratios for all three angles and round to the nearest hundredth. Pause the video and work out the warm-up. The tangent of 30 degrees is 0.58. If you've gotten the wrong answer with using your calculator, make sure you've changed your mode to degrees. The tangent of 60 is 1.73, and the tangent of 90 is undefined. A 90-degree angle is opposite from the hypotenuse, and with tangent calculations being opposite over adjacent, the hypotenuse cannot be included in the calculation. Number 2, find the measure of angle A and angle C using the tangent ratio. Pause the video and calculate your answer. For these two, angle A is 30 degrees and angle C is 60 degrees. So when we look at A, we can work backwards from the relationships that you see here. Angle A, in terms of tangent, is the opposite, which is 4 radical 3 over 12. To solve for A, the missing angle, use tan inverse. And of course, angle C would be tan inverse of the reciprocal. You could also just verify that if the angle A is 30 degrees, then the sum of angle A and angle C have to be 60 degrees. Practice with the tangent ratio. Write the tangent of A and the tangent of B in simplest radical form. So for this particular problem, what you'll notice is that you're given one of the legs of the right triangle as well as the hypotenuse. So we're going to have to do some calculations here. So tangent of A is going to be opposite over adjacent, which is BC over AC. But we don't know the value of AC, so we're going to have to calculate it using Pythagorean theorem. So this is the three sides of the right triangle. The unknown is AC. You're going to square 2 radical 6 all squared for BC squared. So you're squaring the 2, and you're also squaring the radical 6, and then you have 5 squared over on the right-hand side. 2 radical 6 all squared is 24. Subtract 24 from both sides. You'll get AC squared equals 1. When you take the square root, you'll get AC is 1 as well. So we have, for our tangent of A, we're going to have 2 radical 6 over 1, which is opposite over the adjacent, which simplifies to 2 radical 6. Tangent of B is simply the reciprocal of these two values. So this is going to be 1 over 2 radical 6. Keep in mind you do have to rationalize your denominator and get rid of the radical 6. So multiply the top and the bottom of your fraction by radical 6. And you're going to get radical 6 over 12. Find the measures of angle A and angle B. You're going to be using tan inverse. So angle A is the tan inverse of 2 radical 6 that you have up here, which is going to be 78.46 degrees. So using subtraction, angle B has to be 90 minus this amount, or you can do tan inverse of the reciprocal, which you simplified up here, which is 11.54 degrees. Example 2. Solve for the variable to the nearest tenth. Verify your answer by solving using the other acute angle. So we have a side x, and we know that the angle is 36 degrees, and we know that the adjacent side is 52. So we're going to set up a tangent ratio for this particular problem. So we say that the tangent of 36 equals x over 52. To get x by itself, multiply both sides by 52. And using your calculator, you'll get 37.8. You can check this as well. If you take the tangent of 54, which would be the opposite other angle from the 36, it would be the one that's complementary to it, and that's 52 over x. You can put a 1 underneath the tan 54, and then you can cross multiply. So you would have x times tan 54 equals 1 times 52. And then you would divide both sides by tan 54. Using your calculator, you also get the 37.8. So that verifies either way that the x value is 37.8. Letter B, go ahead and do this one on your own. Pause the video and check it when you're finished. Solution. Tangent of 21 equals 30 over x. Put a 1 underneath your tan 21 and cross multiply. And ultimately you'll divide by tan 21 on both sides and you get 78.2. You can verify that with the other angle. The other angle would have to be 69 degrees. And solving a cross multiplication with a proportion, you get 78.2. Example 3. In a rhombus, the angles are 80 and 100 degrees, and the shorter diagonal has a length of 10. Find the length of the longer diagonal to the nearest tenth. So the first thing that you would want to do is set up the drawing appropriately. Make sure that you're drawing a rhombus where all four sides are congruent, and make sure that the obtuse angle is labeled with 100 degrees and the acute angle is 80. Additionally, you'll notice that you have two diagonals. The longer one goes through the acute angle that's 80. The shorter one goes through the 100-degree angle. Notice your diagonals also meet at right angles, so you have right triangles built into the rhombus. The shorter diagonal has a length of 10. Well, as we all know from prior sections, the diagonals of a rhombus bisect each other. So that means these two values are both 5s. To find the length of the longer diagonal, you first want to go ahead and find the length of half of it. Because of the fact that these two segments are also congruent, I can calculate the upper half in a right triangle and then double it for the total. So I have an unknown length of x, and I know that these angles are 40 and 50 because of the fact that the diagonals of a rhombus bisect the opposite angles. Setting up a trigonometry function, we have that the tangent of 50 degrees is opposite over adjacent, which is x over 5. You could also have done the same thing for 40. You could have done tangent of 40 equals 5 over x. And that's what I have over on this side. So to calculate both of these, this first equation you multiply both sides by 5, and then using your calculator, you get 5.96. And for this one as well, you would cross multiply, but you'd also have to do an extra step of dividing by tan 40. And this one also would give you 5.96. So when you double this, you get 2 times 5.96, which is pretty close to 12. So the longer diagonal is about 12. Example 4. Write the tangent of 30 degrees and the tangent of 60 degrees in simplest radical form. Now, because they're asking for simplest radical form, you're not going to use your calculator. You're going to draw your scale factor triangle. That's a right triangle. And in a 30, 60, 90 triangle, if you use a scale factor ratio, you'll see that the shortest side across from the 30 is a factor of 1. The hypotenuse is twice that amount. And then across from the 60 is the square root of 3. So the tangent of 30 degrees is opposite over adjacent, which is 1 over radical 3. You'll need to rationalize your denominator for this by multiplying the top and bottom by radical 3, which will ultimately give you radical 3 over 3. The tangent of 60 is the opposite, which is radical 3, over the adjacent, which is 1. So you have radical 3. Example 5. Find the value of x to the nearest tenth. You'll notice that you have two triangles in this picture, and you have some missing pieces here. If you look at the 61-degree angle, it's opposite from the side that's x. However, there's not enough known about that triangle to do a tangent calculation. So you may need to start with the smaller triangle. Now, since we're going to have to do two calculations, it's good practice to avoid rounding until the end of the problem if possible. So I'm going to first work this triangle that I'm calling triangle number 1, which is this small one right here. We'll call this triangle 1 and this one triangle 2. So triangle 1, I can do a tangent calculation here. I'm really looking to first calculate this altitude of the triangle right here. So that's what I want to do first. And I can calculate that with the tangent ratio. The tangent of 37 is 40 over this unknown altitude. And we can call that A. So I'll label one A here. There we go. So cross multiplying here, once again, you can put a 1 underneath this tan 37. And cross multiply. And ultimately you'll have to divide by tan 37. So A is 40 over tan 37. You can certainly leave this to put into triangle 2, which would give you an exact answer. It's probably the best option. If the math overwhelms you, you can also turn it into a decimal and then use it in the second triangle. So now that we know side A, which is the altitude of the big triangle, we can do a tangent relationship for the 61, the x, and this new A value. So we have tangent of 61 is now x over A, whatever we calculated in this scenario. So when I solve for x in this problem, I'm multiplying both sides by a, and I get x equals a tan 61. I'm going to put 40 tan 37 in where a is at. And then I'm just going to use my calculator to multiply, and I get 95.8. This next section talks about vocabulary, and it talks about the different types of angles that are made with a horizontal. The first vocabulary word that we need to talk about is the word grade. Grade is the slope of a surface, or it's equal, or it equals the tangent of the angle of the elevation expressed as a percentage. That sounds kind of confusing. So let's talk about something that we are familiar with from Algebra 1. If you pretend that this is the the y-axis, and this is the x-axis here, you could connect. Let me see if I can find a smaller little drawing here. You could use this. You could pretend this line is passing through the x and y axis and has some sort of a slope. And slope is known as rise over run. Of course, you see this rise over run that's written down here. In this problem, you'll see that the rise is 4 and the run is 10. So if I'm moving from this lower point to this upper point, I'm going up 4 over 10 or over 10 up 4. But either way, it is rise over run, which is 4 over 10. In decimals, it's 0.4 or 40%. So what you'll see in most calculations for these problems is a comparison based on percentage rather than saying slope. So if I look at 6a here, the grade of a road is 3%. In other words, the tangent ratio is 3% or the slope is 3%. What angle does the road make with the horizontal? So what this is saying is that the tangent of some unknown angle is 0.03. That's the rise over run. So another word for grade is tangent. So to solve for x here, I need to get rid of the word tangent, so I'm going to multiply both sides by tan inverse. So using your calculator, tan inverse of 0.03 is 1.72 degrees. That doesn't sound like it's all that steep, but if you're on a road with a 1.72 degree grade, it would visually look kind of steep. Of course, the grade itself, is 3%, but the actual angle is 1.72 degrees. 6b. This is the reverse type of calculation. A road climbs at a 10-degree angle with the horizontal. What's the grade of the road? So the angle size this time is 10. So the tangent of 10 degrees will give you the grade. When you do the calculation, you get 0.16763. Convert it over to a percentage, which means multiplying it by 100 gives you a 17.63 grade. That's a very steep grade and a very steep angle on a road. The homework for this section is page 309, numbers 19 through 28.